We're going to go over this study guide for our second semester. The first part that I'm going to go over here, has to do with angle relationships. So here, if we take a look, we're given a bunch of pairs of angles, and you just have to identify what the pair is, what we would call it. So if you take a look at 3 and 6, they're over here. Well, they're inside our two lines. So I know it's going to be interior. And then if you take a look, it's on the same side of our transversal. So it's not alternating. It's going to be called consecutive. So it's consecutive, and then they're on the inside. So consecutive interior. If I take a look at 4 and 6, they're both again on the inside, and now they're alternating. They're on different sides of that transversal. So this one, not quite consecutive interior, but alternate interior. And I spelled that wrong. Alternate interior. Just kidding. Okay, alternate interior. Now, I'm just going to keep going. 1 and 7. If you take a look, they're on the outside. So those are going to be exterior. And then they're still alternating. So alternate exterior. Here, angle 4 and 6. These ones, if you take a look, a lot of you said like one's on the inside, one's on the outside. But for me, I see them, they're in the same corner. See how they're both on I guess on the left side here, and then in the middle. If you look at a box here, maybe you would say it's the bottom left. Same thing here, the box, it's in the bottom left. So these two angles are in the same corner. They are called corresponding angles. All right, 2 and 6 now. Here, they're both on the outside, on different sides of the transversal. So alternate exterior. 2 and 6. Again, both in the same corner there. So they are corresponding. All right, this last one is one that is kind of like review from IM1, but these ones aren't going to be any of those consecutive, interior, alternate, exterior, corresponding. These are angles that are across from each other, so we call them vertical angles. All right, so that's all those different angle pairs: consecutive interior, alternate interior or exterior, corresponding, and then we do have vertical. There are some others like the complementary and supplementary, but those have to do more with the angle degrees. All right, number 2 here. So both of these lines are parallel, and the measure of angle 7 is 125 degrees. So that means we could apply all the rules that corresponding angles are congruent, alternate interior, alternate exterior, vertical angles, those are congruent, although you don't need parallel lines for vertical angles. And then also consecutive interior angles, so like 3 and 5, for example, they add up to 180. So all you have to do is kind of fit the puzzle pieces together. So if 7 is 125, then I also know angle 3 is 125, angle 11 is 125, and then here, angle 15 is 125. And then if I wanted to figure out what angle 5 was, well, if you remember, angle 5 and angle 7 form a whole line with the two of their angles. So it's going to be 180 in total. So angle 5 here has to be a measure of 55 degrees. And so then angle 1 over here has to be 55 degrees, angle 9, angle 13, and so on. So all of these angles here that I'm highlighting in blue have to be the same. And then if you use the fact about vertical angles, we know angle 6 is the same as angle 7. Now angle 2, and then 3, of course. 10 and 11 are the same. 14 and 15 are the same. And then so angle 4, angle 12, angle 8, and angle 16. They're all 55 as well. So we kind of just figured out all of the angles here, and you just have to write out which one's which. So angle 12 is going to be 55 degrees. Angle 11 is 125. Angle 5 is over here. It's 55 degrees. Angle 2 is going to be 125. Angle 14 is also 125. And angle 9 is 55 degrees. All right, moving on. Here, number 3, it says, which of the following is not a way to prove a quadrilateral is a parallelogram? So, some facts about parallelograms are that the diagonals bisect each other. We know that both pairs of opposite angles are congruent. And then also, both opposite sides are congruent and then also parallel. So if we read through these, A says, show the diagonals of a quadrilateral bisect each other. So that's true. So it is going to be a way to prove it. So that one's fine. That's not going to be our answer. B says one pair of opposite sides of a quadrilateral are both parallel and congruent. So it says one pair, and that works. It's one of our proofs, although even though I said both pairs. Here, C, it says show one pair of opposite angles of the quadrilateral are congruent. Here we also have both pairs of angles are congruent. And both of them have to be congruent, not just one pair. And then here, letter D shows both pairs of opposite sides of a quadrilateral are congruent. That one works as well. So the only one that does not prove, that it must be a parallelogram is letter C, because we need both pairs of opposite angles to be congruent. We could have a weird shape like this here, or kind of like a kite. A kite would be I can't really draw one, but a kite would be an example where it's like this here. So like these two angles could be congruent, but the top and the bottom, they wouldn't have to be congruent. All right. Number 4 here, it says choose all the true statements. So just read through them and use those facts. A parallelogram is a rectangle if and only if its diagonals are congruent. That is true about rectangles. Here, a parallelogram is a rhombus if and only if diagonals are congruent. So rhombuses, they don't need their diagonals to be congruent. So maybe this might be our answer. Or not an answer, I mean. It says select all the true statements. So I'm going to cross it out. A quadrilateral is a square if and only if it is a rhombus and a rectangle. That is true. A square is a rhombus and a rectangle. It has both those properties. Letter D, a quadrilateral is a rectangle if and only if it has 4 right angles. That is also true. So here, A, C, and D, or D, C, and A, are true. All right, number 5, this one has to do about rhombuses. So think about a rhombus here. We know all the sides are the same. We know the opposite angles are congruent because it's a parallelogram. We have some facts about the diagonals. The diagonals are congruent. As we mentioned in number 4, that does not have to be true. So this might be our answer because it's asking what's false. Letter B, each diagonal bisects the pair of opposite angles. That's true about parallelograms and rhombuses. All four sides are congruent. That is also true. And the diagonals are perpendicular. True. So the only one that is false is letter A. All right. Here, last one about like parallelograms and quadrilaterals. This one is about rectangles. It says some rectangles do not have, so hopefully you know what a rectangle is. Rectangles do have right angles, four right angles. So this is going to be true. Do they have congruent diagonals? That is true. Do they have four congruent sides? Well, they don't have to. That would be a square. So it might be letter C. And then here, diagonals that bisect each other. That's true about parallelograms. So this one, rectangles, as you can tell in our picture, all four sides are not the same congruent. So C is going to be our answer here.